In this third video, let's talk about proving for all versus using for all. So the last video talked about uh, the difference between for all and there exists, and just tried to drill down into what did for all mean, what did there exist mean. But now let's just talk about for all. And just like in the case of proving if then versus using if then, they look different. So same deal here for proving a for all and using a for all. They'll be different. So you got to keep track. If you got to do this task of proving a for all, don't switch it. Whoops. Don't switch it for trying to use a for all. And same in reverse. If you need to really use a for all statement, don't go about the steps. Don't go through the steps of trying to prove a for all. Right? That'll get you stuck. Okay, so let's talk about proving a for all first. And actually, for analogy, let's compare it to proving if p then q, because there's some similarities. First of all, I want to mention that proving if p then q, there was a way that it's done 90% of the time. It's not always done this way. Okay, what about for proving so that's proving an if then. There's it's not always done the same way, but most of the time it's done this 90% of the time. What about proving a for all? And just to make it real concrete, we needed some specific letters here. So this is proving for all x in S, p of x. Now maybe you had to prove for all y in T, p of y. Then just switch around the letters, right? Now here's the first best part here. Over here for proving an if then, there's a method that's used most of the time, not all the time. For proving a for all, the method that we're about to describe here, it's done 100% of the time. That's fantastic. So you don't have to question yourself, like, should I use this method or not? If you've got to prove a for all statement, you've got to do what's here 100% of the time. That's fantastic, right? So the first step is write let x in S. That's it, period. End of that sentence. This sentence right here should be super short. Okay? Now, if x had already been used, then you just use a new variable instead. Let's just go ahead and pretend that x wasn't used, so we can just copy the letter that was there. Now, let's talk about what this means, first of all. This nice short sentence should be this short. Let x in S. Dot. Period, right? This instructs the reader. You're writing the proof, and this tells the reader to select anything from the set S that they want. And whatever they've selected is going to be called little x throughout the rest of your proof. And you may not know which thing from capital S that the reader has selected, but you got to be able to refer to it, and so you're going to call it little x. Now keep this sentence short. It's really, let x in S or let C in S if x had been used. That's it. No, don't make it any longer than that. This short let sentence, by the way, is not optional. It is required. This is done 100% of the time. Unlike proving if then, where sometimes you assume that p is true, and sometimes there's a different kind of assumption that occurs, which I don't even want to talk about right now, right? So 100% of the time, you got to have a sentence that's like that or like that. Okay. Now, once you've done that, then you prove. Once you've written this, then whatever appears right here, p of x, then you just prove that p of x is true. Now the argument that you give must be generic enough to work no matter which thing the reader selected from S. Okay, so don't go try to prove just some special case. Your argument has to be readable to the reader, regardless of which thing from capital S they selected to be little x. Let me go to the next slide and see if I need to make a comment. Yeah, let's make the comment here actually right now. Often people skip this. Again, this is required to do this thing. And I would like to draw the analogy here. When you prove if p then q, you start with your first line of the proof is something like assume that p is true or suppose p is true. Suppose p, right? So just like there's that first thing that occurs, there's this first thing that occurs. And then you have to work to prove something. Like over here, it just happens to be Q. It's whatever appears after the word then. So you prove that. Just like over here, you prove this. So there's a nice analogy of you got to do something as your kind of setup sentence, and then you prove something. So over here, your setup sentence is fully written out like this, and then you prove a thing, right? So there's quite nice analogy to the proving if then, if you ask me. Okay, just some comments. Let's just say this. So let's say we had to prove for all M and V, the store sends M. Presumably M is a person who goes to that store, as a customer of that store. For all M and V, the store sends M a coupon book. Now, proving this should start with the sentence, your proof could start with the sentence let M and V. Or it could start with the sentence let T and V. So maybe, just some letter that hasn't been used in your proof in V, right? Now, skipping the sentence let and then whatever your new variable is in V, skipping that sentence, not writing this in your proof, is considered an error. It means that you don't have a correct proof. And sometimes people kind of just manage their way to get through a proof otherwise, but many other times, really, there are situations where people just literally get stuck and can't get any further because they haven't done this step. It really happens. So it's not worth it. If there's something that has to be done 100% of the time a certain way to be correct, then just do it, form that habit. By the way, you should never write a sentence whose format is let new letter in V, like right up there, such that, and then some additional text. This is why I was saying earlier, you got to keep it short. It's just let, new letter, in, set, period, and that's it. Okay, this is problematic to write a sentence in this format. We'll describe why in a future video. Keep the sentence short. It's going to be let, then the new variable, then your in, your membership symbol, then the set that's in question, and then a period. That's it. Okay, so that was proving a for all statement. Now let's talk about using a for all statement. For an analogy, let's talk about using if P then Q, right? So even here, to use an if then statement, was this that we had mentioned before. This doesn't even happen all the time. Most of the time, this is what happens. But this doesn't even happen 100% of the time for using an if P then Q. There's some other ways to use an if P then Q that I don't really want to talk about right here, right now. For using a for all statement, oh, sorry, let's make this comment. To use, we needed this and we needed this. You can't just use if P then Q on its own. If you just know if P then Q, you can't gain any other new fact meaningfully. This fact together with this fact had to together meaningfully combine in order to give us the conclusion Q. So I say this because needing two things like this as well as that, we have an analogy to that in using a for all statement. So let's take a look at this example. Again, let's go with V as a set of all customers of a store. How could we use the statement for all M in V? The store sends M a coupon book. So by analogy, I've stuck like sort of the big statement we're trying to use like over here. So for all M in V, the store sends M a coupon book. Now this is a statement trying to talk about every element in V. And there's got to be something over here so that these two statements, if both true, could combine to meaningfully give us a concluding statement down here. So let's just say it's this. Let's say it was Mickey, like Mickey Mouse in V, right? So how do we combine for every element of V, the store sends M a coupon book, together with, let's say that Mickey is an element of V. These two things, think about it on your own for a sec. These two combine to give us this statement here. The store sends that Mickey a coupon book, right? Does that make logical sense to you? That's the right conclusion. If something's true for every element of V, that's how this should work. And take a look here. This concluding statement right here, it just picks up right after this comma, right? Yeah, I capitalized the T, sure, but the concluding statement, I want to point out, doesn't have for all in it. So how do you use a for all statement? You end up, the final concluding statement doesn't have for all in it anymore. That part gets chopped off. It's like here, this is a generic statement, right? This is about every element of V. This is a statement about a specific element of V. Oh, and that's the other important thing to say. Just like over here, you needed something, right? What's that thing you needed here? You needed a specific element of V. So just like over here, to use if P then Q, we needed P to be true as like this additional thing. In order to use for all M in V, comma, something, we needed a specific element of V. If you don't have that, then you can't use this statement, right? So for me, if I know I need to use for all m and v, comma, whatever text appears next, and I haven't, maybe right away you don't have an element of v. That happens. But the moment I have an element of v, the moment I know I have a specific element of v, my brain is saying, oh, I can combine those two and then I get this. That's what I tend to do. Okay, and then just to wrap things up and review, using for all versus proving for all, they look very different, right? To use for all x and w, p of x, you need to know, sorry, there should be a double quote ending right here. You need to know of a specific element in w. And maybe that specific element, let's just call it y. And then you conclude just what appears after the comma here, just the thing in square brackets. You just conclude p of y. You don't conclude for all y in w p of y, or something like that. So it's a very common error, by the way, when you need to use this statement for people to write let x and w, right? But if you need to use this statement here, writing let x and w looks like the person's trying to prove this statement. Okay? So it's not let x and w. That's the start of, that's the instruction to the reader for the reader to pick from w any element they want. Instead, you need to already have a specific element of w, which over here was called y, and then you get to conclude something specific, right? Instead of having this overly generic statement. Okay, and again, proving a for all and using a for all look very different.